Okay. First, we learned how to expand a determinant of order 3. Order 2 we learned first. Or how to find the value of this determinant?
Cross multiply.
Yes, sir. Cross multiply.
2 into 1. Cross multiply this by
Minus
Minus
4 into
3
3.
4.
3
4
into
into 3 into
4 into 3 or 3 into 4. So 2 minus 12. So the value is minus 10.
minus 10.
Minus 10.
Then we learned that is cross multiply and subtract. It is the shape of R. This into this minus this into this. Then we came to a 3 by 3. 3, 1, minus 1, 2, 1, 4, 1, 2, 3. If you expand this determinant, how you get the answer?
3.
Number
Yes,
3.
sir.
3.
Right with
It
value.
will be 1 into 3.
1 to 3.
3 minus 8.
8.
3 minus 8.
8.
Always between sign is minus.
Yes, sir. Then
No.
minus
The second
1.
number should start with a negative sign.
Yes, sir. So it will be
The first number is positive and last number is positive. Now what I should do?
it will be
3
Now-
minus 4
6
into
minus
1.
4.
Delete this column and this row. So
It will
2
be
into 3
6 minus 4.
6 minus 4.
minus 1 into 4.
4.
Next number
Plus.
with the positive sign.
Plus
Yes.
But the number itself is negative.
Then delete the row containing this and column
And
containing
column.
this. You have only
so it
this
will
one.
be
4
4
minus
into
1.
4 minus 1.
You can calculate and get the value.
Yes, sir.
This is what we learned last time. Am I right?
Yes,
Yes, sir.
Probably have not attended last class, just revised it.
minus 1.
Then I was teaching you properties. So you can also write down the properties. First property I taught you is if two rows
Or columns are identical, then
column.
determinants are 0.
are identical,
Then the value of determinant is 0.
then value of the determinant is 0. For example, 1, 2, 3, 1, 2, 3, 4, 3, minus 1. This value will be 0. 1 minus 1, 2, 1 minus 1, 2, 3, 4, 5. The value also will be 0 because here row 1 and row 2 are identical. Here column 1 and column 2 are identical. So the value of the determinant is 0. This is property number 1. Property number 2. Suppose I have a determinant like this. Look at this. 5, 3, 10, 2. Atharva will never come on time. Okay. That is equal to 10 minus 30 gives you minus 20, right? Did you see that 5 is common in the first column?
Yes, sir.
5 outside and write 1, 2. Check whether is this correct now. 2 minus 6. So 5 into minus 4. That is also minus 20.
20.
That means if you want to take a number common, you need to take it from row or from column. So how can you write this one? 10, 20, 30. Then 3, minus 1, 2, 4, 1, 2.
Sir, you take 10 common from the first row.
And then write 1, 2, 3, 3 minus 1, 2, and 4, 1, 2. Is it clear to you?
Yes,
Yes, sir.
sir.
Okay, now you tell me this. 10, 20, 30. 100, 200, 300. 1 minus 1, 2. So what I can do from the first row?
10, you can take 10 common.
From the second row.
100.
100.
And what do you notice now? 1,
It
2,
will be 1,
3.
2, 3.
1,
3,
2,
1,
3.
2.
So now what is the value?
0.
Answer is
0.
This
0.
value is 0. So the whole answer will become 0.
0.
Because two rows are identical. So how to
Oh.
take common? I've taught you. And also, I taught you the property that if two rows are identical, the value is 0. So you can write down the property number 2 in this manner. Write the property number 2. What do you mean by a multiplication of k with a determinant? Or taking common, both ways you can speak. This is, you can multiply any row with the k. Multiplying the value of the determinant by k is equivalent to multiplying any row with k or any column with k, but only one of them, not all of them. Did you understand this? It should
Yes,
be
sir.
multiplied only by one of the row
One of the row.
or one of the column. So if multiplying a determinant by k is equivalent to multiplying any one row or any one column by k. So whole value of the determinant gets multiplied by k means either any row is multiplied by k or any column is multiplied by k. So you could have written this is also equal to k a11, k a21, k a31, then a12, a22, a23, a32, then a13, a23, a31. I hope you understood property 2.
Yes.
Is it clear?
Yes, sir.
Yeah. So are you writing this property? 3. Property number 3. What can you say about this determinant's value? 3, 1, 2. 1, 2 minus 3, 4, 1. Now, first row, I am making it first column. Second row, I'm making second column. Third row, I'm making third column. What can you say about their value? Will they be equal or not equal? I interchange the rows and columns. What can you say about the value of determinant? Yesterday I taught you.
Yes,
I
sir,
taught you
equal.
equal because I taught you there are 2 ways you can,
Yes,
not
sir.
too many ways you can calculate that.
Many ways.
Yes, yes, equal. Yeah. In this way, if you calculate or this way you calculate, the value of determinant remains the same. So the value of the determinant remains the same. So what you'll say? Property number 3. If rows and columns are interchanged, then value of the determinant remain the same. You can write this example. Write this example. 4. I'll show you with a 2 by 2. 3 plus 2, 1. 4 plus 3, 2. I'm writing it as 3, 1, 4, 2 plus 2, 1, 3, 2. We have to check whether left hand side and right hand side are correct or wrong. Okay. What is the value of this determinant? 5 into 2, 10 minus 7 into 1, 7. So I got how much answer?
3.
Let's see the right hand side. 2 minus
6
4
minus 4.
plus 4 minus 3. How much you get the answer? Minus 2. How much you get the answer? 1. Minus
Sir,
2.
it should be 6 minus 4.
6 minus 4. Correct. So plus 2. So are you saying both the sides are equal?
Yes, sir.
Yes. So what we have learned here is you can split a determinant into sum of 2 determinants. That is what is the property number 4? A1 plus A2, B1 plus B2, C1 plus C2. And here you have, let's say, A3, A4, B3, B4, C3, C4. Then this can be splitted as A1, A3, A4, B1, B3, B4, C1, C3, C4 plus. Now instead of first row you have taken A1, B1, C1. Now you will take the first row as A2, first column as A2, B2, B2,
And
A3, B3, C3, A4, B4, C4. Did you follow that? This is applicable not only for one row, for all. Even for column you can apply. You can apply for rows, anything, any row or any column. Is it clear?
yes, sir.
If each element of a row, bracket or column is expressed as the sum of two numbers, then the determinant can be expressed as sum of two determinants. As shown above. Did you follow that? How to split it? Is saying each row is expressed as sum of two numbers. Every row or column. Here I took column. First column is expressed as sum of two numbers. Then the whole determinant can be expressed as sum of two determinants. Is it clear to you? Property number, how much it is? 4, no?
4.
Yes.
In property number 5, look at this. 2, 3, 4, 1. Calculate the value. 2 minus 12 minus 10. Now what I'm going to do is, first row I'm going to make it as second row, and second row I'm going to make it as first row. I interchange the rows. What did I do? Interchange
The rows.
row 1 and row 2. Now the value became what? 12
Positive.
minus 2.
10
It became opposite.
plus 10.
Value became opposite sign. So what we
Yes.
can say? If two rows or two columns are interchanged, then value of the determinant changes by sign. By sign. Positive will become negative, negative will become positive. So what I can say? A11, A12, A13, A21, A22, A23, A31, A32, A33 is equal to minus, let's say I interchange the first two column 1 and column 2 I'm interchanging. So what will become? A12, A22, A32, and here A21, A22, A31. And here A13, A23, A33. They will have a difference of only minus sign. If I interchange two columns, the value of the determinant changes only by sign. Is it clear?
Yes, sir.
Look at this. 1, 3, 4, 5. This is called row 1. This is called row 2. I am going to multiply row 1 with a number k and add to row 2. So my new row 2 is obtained by multiply the first row with k and add to the second row. So 1, 3, which row is changing? Second row is changing. How it is changing? Multiply this with any number k and add to it. So 4 plus k. Multiply this with the k. So it becomes 3k. Add to it 5 plus 3k. Now let's have a look at its value. This one's value is 5 minus 12 gives you how much? Minus 7. What will be the value of this? 5 plus 3k into 1 minus 3 into 4 plus k. What do you notice when you open the bracket? Did you notice that k goes away? Did the value of the determinant change?
Yes.
What is the
No.
original value?
Oh, no. It didn't change.
It didn't change. So if you multiply, so let's say we have 5, 3 and 1, 4. If I add the first two rows, let's say R1 and R2 I'm adding. Which row is changing? R1 is changing. What will be my answer? 5 plus 1, 6. 3 plus 4, 7. 1, 4. Look at both the value. This will be how much? 20 minus 3. This will be how much? 24 minus 7. Are they both? This is 17. Is this also 17?
17.
Yes. What did I do here? Between R1 and R2, I added. Even if you subtract, let's say I'm R1 minus R2, I do. 5 minus 1, 4.
4.
3 minus 4, minus 1. Did you notice that whatever the operation you are doing with one element, it has been repeated with all? You will get 16 minus of minus 1. Did you get 17 again?
Yes, sir.
Yes. So what do you mean by all this property? When you say any row can be multiplied with a number and added to another number, the value of the determinant does not change. If k becomes minus 1, if you multiply with minus 1, that means subtract 2 rows. If you directly add 2 rows. So if you do R1 plus R2, R1 minus 2 R2, R1 minus 3 or 4 R2, anything you do like this operation with all the row, the value of the determinant does not change. Is it clear to you? Did you understand this property?
Yes, sir.
So tell me, if I do this 1, 5, 4, 3, 2, 1, 1 minus 1, 2. What I'm going to do? Multiply this with a 10. C1 is going to be multiplied with a 10 and added to C2. What will happen? Let's see. Which is changing? C2 is changing. I'm multiplying with the 10 and adding to it. So what is not changing? Let me write down. These both are not changing. Multiply this with 10 and add to it. Become 15.
15.
Multiply this with a 10. 30. 30 plus 2. 32. Multiply this with a 10. 10 minus 1, 9.
9.
Will both have the same value or different value?
Have the same value.
They both will have the same value. Did you understand?
Yes, sir.
Yes, sir.
So write down the property number.
6.
Property number 6. If any row or column is multiplied by a number and added to any other row, then value of the determinant remain the same. Any other row or column here. Okay. Value of the determinant remains the same. Example 1, 4, 2, 3 is 3 minus 8 minus 5. R1 you multiply with k and add to R2. R2 dash plus, usually we write the one which is changing first. What I'm doing, R2 add k times R1. So which row is changing? R2 is changing, R1 is not changing. What should I do? Multiply this with the k and add to it. So 2 plus k. Multiply this with the k and add to it. 3 plus 4k. what happens? Then you can take the value 3 plus 4k minus 4 into 2 plus k. Open the bracket and show how that k gets cancelled. You will notice that k gets cancelled and it comes back to the original answer. So this k does not affect our answer. You can do that with column also. Suppose C1 plus k times, or C1 plus C2. I'll do C1 plus C2. K is 1 here. C1 is equal to C1 plus C2. So 1 plus 4, 5. 2 plus 3, 5. And look at the value 15 minus 20. You will get again minus 5 as answer. So the value of the determinant does not change. If you add 2 rows, add 2 columns, subtract 2 rows, subtract 2 columns, multiply a column with a number and add to another column, the value of the determinant does not change. These are the fabulous properties of determinants. Because of this property, many calculations can be done very easily and formulas can be simplified. That's the benefit of this property. Is it okay?
Yes, sir.
Yes, sir.
Have you written this or still writing?
Done, sir.
Done, everybody? Okay, then let's do some problems on this. Okay, before that, can you calculate this? This I'll put C. If you expand this determinant, what we'll notice, your answer will be the product of this diagonal. Your answer will be AC here. It's not a property, it is an understanding. If all elements above the diagonal, all the elements below the diagonal are 0, if you expand it, you will get the product of the diagonal as your answer. Is it right or not? A into CF minus E into 0 it will become. And remaining all are zeros.
Yes, sir.
So naturally ACF would be
ACF.
your answer.
ACF.
Yeah. So 5 2 5,000 0 1 5,000 0 0 2. What will be the value of this determinant?
10.
10.
5 into 1 into 2. Value will be 10. If the either above the diagonal or below the diagonal, if the values are 0, all elements are 0, then the value of the determinant is product of the diagonal. Is it fine?
Yes, sir.
Okay. So it is convenient for us whenever we want to calculate the value, make them zeros, so calculation becomes easy. All right. Now, are you ready to write that? You noted this?
Yes.
Yeah. You don't call it as a property. You can just note it. Now write the first question. Without expanding, find value of the determinant. Exercise number 4.2. Question number 1. 1A B plus C. 1B C plus A. 1C A plus B. I'm not supposed to expand it. Without expanding, I should find the value of the determinant. What I'll try to do? Tell me. What I'm going to do is, if I add column 3 with column 2, which column is changing? Column 3 is changing. Which is column 3? This is column 3. I'll use some other color. Otherwise, you will get confused. Column 3. This is column 2. Just add and tell me the answer.
A
One.
plus B plus C.
One,
A plus
one.
B,
A, B, and C. A plus B plus C.
A plus
A plus B plus C, right? Next
Yes.
also will become.
Same, same.
A plus B
Next
plus
also
C.
will become.
Same.
C plus B.
So what is common in on the third column? So if you have a number
A.
common in the third column, I can take it outside the determinant.
Hmm.
Mhm.
So now what it became? 1, 1, 1.
One,
A,
A,
B,
B,
C.
C.
Because A plus B plus C is taken common, this will become 1, 1.
1,
0.
This answer becomes 0 because
Zero. Because
C1
two rows
equal
are
to C2.
common.
Column 1 and column 3 are same.
Column 3 are same. Did you understand?
Yes,
This
sir.
is how you, by using property, you can calculate the value of determinant without expanding. We didn't expand anywhere. We used only properties. Have you noted?
1 second, sir.
Yeah. Can
Done,
we
sir.
do question number 2? Yeah.
Yes.
Yes, sir.
Question number 2. You have to find the value of this determinant. 2, 3, 4, 5, 6, 8. And then 9, 6x, 9x, and 12x. So do you have anything common here?
3.
Not only 3, 3x, no?
X,
X
X
Yes,
also
3x,
common.
sorry.
So
3.
taking 3x common from where? From
Row
row
3.
3.
Row 3.
Yeah, row 3, from row 3. So this is equal to 3x goes outside the determinant. 2, 3, 4, 5, 6, 8, 2, 3, 4. Right? 3x into 4 is 12x. 3x into 3 is 9x. 3x into 2 is 6x. Is it fine?
Hmm.
Now tell me what is the value of this determinant?
0, sir, because
0.
first column and second column are same.
Since
Third column.
R1 is same as R3. Since two rows are identical, the value will become 0. Is it fine?
Hmm.
Question number 3. 2, 7, 65. 3, 8, 75. 5, 9, 36, 86. You have to find out the value of the determinant. What will you do? What method will you adopt so that you will get the value of the determinant? Any idea?
So can we convert them into addition in the two parts?
Then again, the one part you may make 0, then again other part, little more faster method. Look at, by taking difference or something, we can make two rows identical or something like that. Now you have to think and tell me. Anything common in the last row? Is it multiple of any number? Is it multiple of any number?
Hmm.
Then what to do? Anyhow, if you have not got any idea, just reduce them. Any difference you see? Here 5, here 5, here 4.
Four.
Correct now? So 5,
Hmm.
5, 5, 4. Here any difference? 10, 11. Anyhow, this big numbers let me reduce to smaller number. R2 minus R1 I'm doing with the intention of making big numbers small. 1, 2, 3 minus 2, 1, 8 minus 7, 1, 75 minus 65, 10. Did you understand this? New R2 is obtained by, from R2 I subtracted R1. All of you agree with this?
Yes, sir.
Okay. Then what we can do? If you subtract this, what you'll get? Okay. Then let me see. R3 dash is R3 minus R2, R1. What you'll get here? 3, 2, 11. It is 65 minus 86. How much is that? 21. Any other possibility? If you multiply this with a 9, oh yeah, I got a better method. This whole number, I'm going to make it very small. If you multiply this number with the 9, how much you get?
63.
What is the difference?
2.
2. Multiply this both. 8 into 9.
72.
72. X
Difference. What is the difference?
3.
3. Take that. How much?
81, 86.
81.
5, sir.
The difference.
Then
difference.
Then it
You see,
becomes
both will
0.
become
then
same.
common.
5.
So
0.
C2, C3 is equal to C3 minus 9 times C2. Is it okay? C3 minus 9 times C2. So what will be my answer? There's no change. There's no change. Now multiply this with 9, 63. 65 minus 63. That will give you 2. Then the next one is what? 75 minus 9 into 8. How much is 9 into 8? 72. So that will give me 3. Then next is what? 86 minus 81. That will give me 5. Is it okay?
Yes, sir.
Now what you can say about the value?
0.
Value of the determinant is 0 since C1 is equal to C3. Did you follow that?
Yes, sir.
So I'll explain once again. First of all, what we have noticed, we wanted to prove this. So there were two terms, but here we had only one terms. So this is working on number of terms. Idea comes to you by looking at the number of terms. There were single term in my right hand side, but two terms on the left hand side. First thing what I notice is, if I add this 3, and if I add this, all of them will give me same answer. So my first operation is to C1, add C2, add C3. So each x will become twice, y will become twice, z will become twice. It becomes 2 into x plus y plus z. Same way, here when we add, same thing happened. Same thing happened. After we do this, we take only 2 common. Although the whole thing could have been taken common, but I have taken only 2 common because my right hand side wants only 2 to be common. So if I take x plus y plus z also common, then I will not come to this answer. I'll get some other answer. Then I saw there are 3 terms here and there are 2 terms here, and my answer requires only 1 term. So if I look at the difference between these two is x. That is exactly what I want. Difference between this and this is x will go away, z will be. That's exactly I want here. So I did C1 minus C2. When you do C1 minus C2, this 3 term and this 2 term difference will give you a single term. And that is exactly what I have here. Then what I did after that, 2 term and 1 term, the difference will give me 1 term. But if I take the difference between this two, I won't get this. But if I take the difference between this and this, I'll get this. So I did C3 minus C1. So C3 minus C1 will give me the answer for the Last one. Again, I saw this is second two terms and this only one term. That difference gives me single term. So I took C2 minus C3 to get the final answer. Is it clear to everybody?
Yes, sir.
So number of terms is the thing that you have to look in this problem. Always look at the right hand side. What do you want? Accordingly, you need to modify at each step. X minus 1. X plus 6. X minus 1. X plus 2. Then X minus 1. X plus 2. X plus 6 equal to 0. Let us solve this equation. You know that whenever we want to solve the equation, you should have product of two numbers is 0. Then only we can get this 0 and this 0 and solve the equation. So your aim is to get a common. You have noticed that X plus 2, X plus 6, X minus 1. Yeah, are they all same terms in different order?
Yes.
Yes.
What should I do? What should I do the first step to get a common term?
You should multiply them.
Multiply, you won't get common. How will you get common if you multiply? Last time also we did. How did I get this common term?
You added all the three.
So whenever I want to take a common term, if you add, just check all three. If I added, will you get the same answer? So I can say C1, new C1 is C1 plus C2 plus C3. How many times X is added? 3.
3 times.
2 plus 6, 8 minus 1, 7. Next also same will be the answer. Next also same will be the answer. But I cannot change this. This has to be written that way only. Only C1 is changing. Tell me what number can I take common now?
X plus 7.
3x plus 7.
Oh, 3.
What will be left? 1, 1, 1.
1.
X plus 6. X minus 1. X plus 2. X minus 1. X plus 2. X plus 6. So I got one term. So x1 value I got. X is minus 7 by 3. Now, but I'm not going to write that answer now. I'll write everything together. Whenever this is a trick which I'm going to tell you. Whenever you see 1, 1, 1, make the 1 zeros and you will get your answer very easily. This is a standardized method. That is only standardized method that you have in this exercise. Whenever you see 1, 1, 1, make the 1 zeros. Okay. So I have with me, I want to make this 1 0. So from R2, subtract R1. My new R2 will be 1 minus 1. Then this minus this. Then this minus this, like that. Same way, R3 also do the same process. R3 minus R1. So 1, X plus 6, X minus 1. That will not change. 1 minus 1. Tell me 1 minus 1. 0.
0.
X minus 1 minus X plus 6.
So
It
it
will
will
become
be
minus 7.
minus 7.
X got cancel. Minus 1 minus 6 minus 7. X plus 2 minus X minus 1. That
Minus
becomes
7 and 1.
3. No? 2 plus 1, 3.
Okay, 3.
Then again, this one with this 0. X plus 2 minus X plus 6. How much you'll get the
It
answer?
will get cancelled and it will become minus 4.
Then X plus 6 minus this and this. X minus 1. That
7.
will become 7.
And 7.
And what is our common? 3x plus 7 is common. And what is your right hand side? 0.
0.
0.
So much is clear.
Yes, sir.
Now what I'll do is I'll expand this 1 into this into 0, this into 0. Do you understand? So you will be left with only a number here. I think that part you didn't understand. Okay, I'm expanding the determinant now. So how to expand the determinant? 3x plus 7 will remain. 1 multiplied with minus 49 plus 12. Next with a negative sign.
X plus 6.
But 0 multiplied with 0, 7, 0 multiplied with the whole 0. Same way here, x minus 7, 0 multiplied with 0 multiplied with becomes 0. Hence the whole answer becomes 0 here. So you are left with 3x plus 7 into, how much this will become?
Minus 40.
So the value of x will be only obtained by equating 3x plus 7 to 0. That is, x is minus 7 by 3. So if the value of x should be minus 7 by 3 to get the answer. Now this much calculation is just I showed you. But once you get this common, you got your answer. Is it clear?
Hmm.
So whenever below the diagonal, if the value is 0, then the value of this determinant is product of the diagonal elements that I taught you now.
Yes.
A, B, C, 0, D, E, 0, 0, F. The value of this will be
ADS.
A into D into F. Same way value of this will be the product of this 3. If the below the diagonal or above the diagonal is 0. Is it fine?
Yes, sir.
Okay, try one more question. If 4 plus x, 4 minus x, 4 minus x, again 4 minus x, 4 plus x, 4 minus x. The next is 4 minus x, 4 minus x, 4 plus x. This is equal to 0. Then find the value of x. What to do? What to do? Tell me. Don't tell me you don't know how to do this.
But add the first
Add all three columns.
columns
Add all C1 plus C2 plus C3.
plus C3.
4 plus 4 plus 12. X and minus x will get cancelled. Then 1x will remain. So 12 minus x, 12 minus x, 12 minus x.
12 minus x will be common.
Correct. And you will take that as common. When you take that as common, what will happen?
1, 1 and 1. Then we have to convert that 1 into 0.
What value of x you already got? What is the value of x here?
12.
12. Yeah. Whenever you see 1, 1, 1, what should be done?
Convert it into 0.
Convert it
Somehow.
into 0. Very good, Anam. Super. You are grasping. Okay. Now converting into 0. I told you this idea. 1, 1, 1. Whenever you get, convert it into 0. And what is the formula to convert it into 0? R2 minus R1. From this row, subtract this. From this row, subtract this. R3 dash is equal to R3
R3 minus R2.
R1. We are always subtracting with this.
First.
So 12 minus x will remain as it is. 1, 4 minus x, 4 minus x. This became 0. When you subtract this both, it will become 2x. Should I explain? When you subtract this both, you will become 8. No, 0. Then this one and this, you are subtracting this both. 1 minus 1, 0. 4 minus x, 4 minus x, subtracted 0. 4 minus x, 4 plus x minus 4 minus x. So it becomes 2x.
So diagonally we can.
The product of this. Below diagonal,
Yes, sir.
everything is 0. So directly 12 minus x into 1 into 2x into 2x equal to 0. Now 1 cannot be 0, which means 12 minus x is 0.
12
Or
minus x
2x
is
should
0.
be 0.
Or 2x is 0.
Should be 12 or x should be 0. So the solution for this equation is 0 and 12. So what are you going to do this? Looks very complicated, no? You can see some numbers are same. 6, 7, 6, 7, 6, 7, 1, 1, 2, 3 is a 3, 2, 6. Can you see here 3, 2, 6? Here 1, 6, 3.
Yeah, there will be 3 to 6.
3, 1, 7. Yeah. You can see 3, 7, 3, 1, 7 here.
Common.
If you take a 2 common here, no. Okay. What I'll do now? I need to make the numbers some similarity. If I
So column 3 divided by 2.
column 2, you multiply with 2.
So no,
Yes, sir, it will be both
This 4,
same. Yes,
from this 4, 1, 2, I'll multiply this.
yes.
Then I'll
So it will
multiply
be 6
another
for
2
12.
with this. 4, 4, 2 will become. Okay, let me do that much. 1, 2, I'll multiply with this. And then I'll think about what to do another. So I am going to write this as 1, 3, 6, 6, 1, 4, 3, 7, 12. This 4, I'm going to split it as 2 into 2. 1, 2 will multiply column 3. 2 will multiply column 1 and other 2 will multiply column 3. So it becomes 4, 4, 2, 3, 1, 7 and 6, 4, 12. Is it okay? Everybody agree with what I've done? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Yes, sir.
Now, did you notice that this column and this column is same as this and this?
Yes, sir.
Yes,
So I
sir.
can add now 1 plus 4, 1 plus 4, 3, 6. 6 plus 4, 1, 4. 3 plus 2,
3 plus 2, 7, 12.
7, 12. This can be done only because two columns are identical. This and this were
Yes.
identical. So only 4 can be added. And that gave me 5, 3, 6, 10, 1, 4, and 5, 7, 12. But I want this answer. I need a 10 common. So I'll take a 5 common from here and a 2 common from here. 5 common from
C1.
C1 and 2 common
2 common from C3.
C3. So 5 into 2, 1, 2, 1,
So it will be
3, 1, 7,
1, 3, 3.
3, 2, 6. See, correct, no?
1, 2, 1.
So my answer became 10 times 1, 2, 1, 3, 1, 7, 3, 2, 6. Now compare my 3, 2, 6 here, my 3, 2, 6 here, 3, 1, 7 here, minus 3, 1, 7 here, 1, 2, 1 here, 1, 2, 1 here.
Yes, sir.
So what do you do? A row and column, if you interchange, the value doesn't change.
It's
So
equal.
interchange column and row. So 1, 3, 3 became first column. 2, 1, 2 became second column.
Second
1,
column.
7, 6 became third column. And that is my right hand side. Understand?
Hmm.
Yeah. So what did I look at? I wanted to combine this two into a single one. If I want to do that, 2 columns should be identical. Then only your 2 rows should be identical to do that. I saw 3, 1, 7 here, 3, 1, 7 here. I could make this both equal by taking from this 4, 1, 2 and multiplying with this. And another 2 I multiplied with this. So that these 2 columns become identical. These two columns are identical. If two columns are identical, third column can be added. So we added the third column. Then we kept on looking at the right hand side and decided one should be common, 2 should be common. Then rows and columns should be interchanged. Is it clear to everybody?
Yes, sir.
Very tricky questions, no? Ideas should strike.